teams. Nice to see all of you.
I started the recording. Avneesh, you can go ahead.
Okay. Um. So.
Okay, I would like to welcome all of the teams for today's session. It's very nice to see all of you joining this session. Special thanks to Team TechInfinity for taking the initiative to talk about the CAD, how CAD could be helpful to us. And very special and nice to see that teams are coming forward to conduct these sessions. I think this is the third session in our competition. We had 2 sessions earlier to this, and this is the third session. So request to all the other teams to also think about talking about and sharing about your work, your difficulty, so that other teams learn from you. This team TechInfinity, we had shared the video with you earlier. They had allowed us to share their robot run video. So now they are talking about how CAD could help you design the robot better. And I request Team TechInfinity to take over the session.
Okay. Hello. Before we start, I would like to ask, like, how many people of you all know what CAD is? Please raise your hands. Okay. So only 2 people. Okay. So we are going to talk about CAD, which is for computer-aided design. So we'll start straight into it. So we are going to use a software called as Tinkercad. Why Tinkercad? Because it's a beginner friendly and it can be easily used, and you don't need to like download it. Because for CAD, for professional CAD, you need to like download a lot of like the softwares. But instead of that, we're going to use a website called as Tinkercad. If you all want, if you all want, you all can do it with me, or you all can see the recording after the video and do it afterwards. Okay. First, I'm going to talk about the basics of CAD, of Tinkercad, and then we're going to start making the claw. So this is our interface for Tinkercad. As you can see, there are a lot of basic shapes over here. Then we have our grid, which is also known as the work plane, and we also have all our other tools over here. So first we're going to go on basic shapes. There are all the basic shapes such as square, cylinder, circle, all those basic shapes. And we also have some special shapes such as a sketch tool, wherein you can use it to draw any shape you want in particular. As such. Then we also have the revolve and scribble. We are mostly going to use the extrude sketch for this session. So first, let's start with all the basics. So I'm going to take this cube over here, and we can easily change the height and size by seeing this. As you can see, you can click on these numbers and you can just change it. For now, I'm going to keep it to 40. This we can set to 50. It just becomes bigger. We can also set the height by clicking on this square. Okay. So now we'll get straight into designing the claw. So first, we're going to take a cylinder and draw. This is meant for the gear of the claw. So what we're going to do is we're going to set this to 30 millimeters and 30 millimeters again. And then reduce the height to about 5 millimeters. Now what we're going to do is we're going to use the sketch plane and put it on the cylinder so that we get this nice orange cylinder as our this as our scale, or you can use it as like a rig so that we know where to arrange the spikes. First, next thing we're going to do is we're going to put off the grid, because if we put off the grid, we can snap to the circle. So what we're going to do is we're going to click on this, and we can set the tooth height to whatever we want. Like we'll set it to right now. You can set it to 1.41, or you can just change it to 2. You set it to 2. Right now, since it's a bit hovering over this a bit, we're gonna put it down. Since this is 2.48, we're going to do the same thing over here. Change it to 2.40. So this creates an like equal this all around. As y'all can see, y'all can see a bit of an like width between this. We don't want that. So what we're going to do is it's going to take the width and then slightly put it off around 0.5 so that you can easily see the tooth. Now we're going to keep back and edit it. Now we'll do the same thing all over the we'll make it until this much only, as we can copy it and do it all around. As you can see, a slight of an this has been formed. So what we're going to do is we're going to press Control V and Control C, Control C and Control V, and we're going to align it with this we have already made. If it's a bit off, don't worry, it will we can change it afterwards. Right now, as you all can see, it looks a bit off at the first area. So what I'm going to do is, as you all can see, I did a little bit of a mistake, and this area over here is a bit bigger than the rest. So what am I going to do is, instead of using like this area, what I'm going to do is take a cube and put it in the exact area where I don't want it hole. As you all can see, it's covering the area. Now I'm going to shift click both of them and then do a bundle view. As you all can see, this part is cut off. This is all just basics if you all want to do it. Now what we can do is we will switch to a more advanced one called Fusion 360. Let me open it up. This is all just multi-designing for those people who don't really can download Fusion 360. So to design the actual claw, we're going to use another one called Fusion 360.
Hello. So I
Yeah.
so I will show you how to design a proper claw with Fusion. So let me share my screen. So can you all see my screen? Can you see my screen? Anyone? Okay. So we'll start with how to design claw. So to create claw, we need to first design gear. So it is already in the Fusion. So we go in this, add in scripts, and you can see years per year. Oh, now can you see? So here this per gear, yes, per gear. So it is option to create a gears easily without to design. So we will go in create, and you can see. uh, Wait. So we'll run this. Um, mm, I think gear is not working. Okay, I will import a gear file. Mm. Okay, so this is gear, and you can see I already added the claw. So I will show how to create gear. So first you will draw circle. If you can change here how much you want. So example, I need 40 mm. So I will add 40. Done. Now to create the tooth of gear, you need this one. We'll zoom in and you'll draw like this. Sorry. Okay, this is one tooth created for the gear. Now you will select this. Then you click on center object. Then this. Now you can see there is gear. tooth around us. You can select how much you want. So this is your gear. If you want to adjust, you can just move this by clicking M. Look, now it becomes gear. We'll add one hole here. So if you're using M4 screw, 4 millimeter diameter, you need to add 4 millimeter. Okay, this is done. Gear. Now we'll do extrude. Extrude means to make a sketch into 3D object. Okay, one. So we'll select all of those like this. Okay, we'll keep gear thickness 4 mm. Why it is not the okay, now your gear is created. It's so as you can see, this gear has been created. Now to make claw, we'll make again sketch on this. Select this surface. Now you'll draw a line for this. Okay, we'll draw a line from here, from gear to down. As you can see, this is sketch is created. Now we'll do same thing. We'll extrude it down. Okay. So you can also do by clicking this. It will automatically align to this thickness. As you can see it done. Now what will go? You will go in sketches and make this here show because it was hidden. Now what we'll do is we'll copy paste this. Mm, okay. Now we'll move to like here. Now as you can see there is a intersecting between us. So what we'll do is we will rotate it little bit. Uh, okay. We'll rotate it 90 degree. Mm, mm. So we'll align like this. As you can see it aligned properly between this. Make sure you keep space between this, what is called backlash, so it won't feel stuck. Can I finish? Same as we did claw that left side, same to do right side. Okay, now we'll extrude it 4 mm. Now what we'll do, we'll make again sketch about this. As same as we'll draw line. Okay, now we'll draw again. If you think this is not enough thickness, you can press M and you can shift towards left. Now we'll do finish sketch. Select this sketch and click this. Now you can see we created a claw. Now for claw we need mounting area, so we can mount servo motor, servo shaft to this. So I will add servo motor. So we inputted the servo motor, which you can find on any website, just like GrabCAD, which you can find like such models of servo motors.
Request to people watching, any doubts, please pause and ask. Because if you have a question like, for example, where you got this servo motor, they can tell you. But please ask questions. There's hardly anybody, so he will not mind you stopping him and asking questions.
I will share link of you can find such like electronics, CAD, servo CAD, other like. So we brought servo motor here. So now we do is the alignment. So as you can see, this is not properly aligned, which can make your working problems. So what we'll do is use joint feature, which aligns them. So we select the center and wait. First we'll remove the ground. Ground means when you add ground option to servo, it will stick to one place. It will not move. So we need to remove to move to towards claw. Now we'll do is rigid group. Rigid group means to make servo all parts one. Okay, now we'll select center one and this. Now as you can see, it properly aligned with the claw and servo. Now what we'll do is we'll take it upward like this. Then we'll make a hole to fit the servo horn. Mm. I think servo didn't come with along with servo on. Okay. Now as you can see it outline. Now as you can see it now almost done. Now we need a mounting. So what we'll do, we'll move all this. We'll move like this. If you want, you can also keep like this for your side. Mhm. Mhm. Now what we'll do is rotate to save space. Okay, now we'll move this. Why it's not moving? Sorry, it's not moving. So we'll do like this only. So to create a mounting for servo, we'll create sketch here. So we'll draw a rectangle for this. So as you can see, we draw rectangle. We also draw circle for screw mounting here and here. Now we need to draw a big rectangle like this. So we draw rectangle and square. Here we also need a hole because to mount this right one claw, so we'll make 4 mm hole. Now we'll add fillet for not pointing. It may harm us to make soft one. Okay. So we now we'll extrude this. As you can see, we made a support for this servo claw. Now we'll click enter. Now we made a M4 screw, so we'll add a screw here from here. Mm. Now we'll go in bolt and screw. This software has the option for many screws. Now we'll add X. Now, now you can see it is screw has come. I can put mm. As you can see, screw has created. Now we'll leave it as enough. Now we need to measure how much we need screw length. So what we can do is select this circle, which is vertex, I think. Then from here, now you will get the size. So we need almost 30 mm screw, 30 or more than. So what we'll do is we'll edit this, edit screw. So we'll then do 30 mm. If you can do more for adding lock nut, which is nut which makes better than nut which has nylon rubber. As you can see, a screw has been created. So what we'll do, we'll same use join feature. We'll just select this and select this. Now as you can see, it perfectly went into the hole. Now what we'll do is leave press the enter. Now what you can do is you can see screw is no support here. So what we'll do is create sketch. We'll make 15 mm support. I think that is good for this. Now click finish sketch and click extrude. I think 14 mm is good. So here we go. We made a claw, basic claw. Now to check the claw, we'll do a which is called motion. Now we'll create a simulation to check your claw. Now what we'll do is build as join. Now before we make a join, we should make a sketch here to make a hole for the claw to attach. Now we'll exit the sketch. As you can see, sketch is created. Now what we'll do is we'll make hole here. I think 2 mm is okay for this. We'll also remove this first, not necessary. As you can see, this circle is remaining. We'll also remove that. Okay, we are made whole. Now you can see it is now perfect to fit in this hole for servo motor. We'll make little fillet so it can go smoothly. Now this is okay. As you can see, we made a hole for this. Now we'll make a simulation. So you can see as build joint, which make which build joints but not movement. It does not move the place of all your servo motors. Okay, now we'll select this and select this. Now we'll choose a point where it should go movement. Now as you can see, it started moving, but this is not end. We'll also do same for this right one, this and this. Now I can see it start moving, but as you can see, it's not synchronized with other. So what we'll do is create also option called as motion link, which will link two motion in one. So we'll select one and other. Now it's moving. Servo is moving. Okay, now we'll low motion link. I think something's wrong here. So we'll delete the joint without anything moving. Uh, uh, yes.
Good morning. Sorry, good
Yes.
evening. I just had a doubt about
Yes.
why didn't you use normal joints?
Means I didn't hear.
Like in the design which you have created right now,
Yes. Yes.
why didn't you use as-built joints?
No, So what is difference in joints and as-built joints? So as-built joint means it will it will make a objects joint, but it will not move. And joint means when you click joint, it will align objects. So
Okay, thank you.
now we'll create a motion link. Now I can see it started moving. Now we'll select the reverse. Now you can see it is properly moving. Both are synchronized. And now we'll set a limit for this because it kept moving like this. So in physical it will not happen. So we'll set limit uh, edit joint. So we'll select minimum. And this is maximum. Now we are proper. As you can see, we're done with claw. So anyone have questions about this?
Okay, now that we've learned to do a basic claw in this, we can learn how to do a basic chassis. Yes, I'll share my screen.
Does anyone have question about this claw? Does anyone have question about claw? So we can move towards chassis designing. I think no one have. Onish, you can start.
Okay. So over here is a chassis that we've designed before. We're not going to do like this, but we're going to do a simpler chassis in a Fusion C60. So we're going to hide this. First of all, we have to create the base. So we're going to do a create sketch and set it to the base grid. Like press capture position. So first, we're just going to create a rectangle. So we're just going to create it. So we're going to use the same size as this. So what we can do is, if you all wanted to create some replica of an CAD design also, but you want to make your own this. So what you will do, will click a point here, click one point here. It's 165.231. And over here, it is, if we see that, we measure this, it is 188. So with that, what we're going to do is, we're going to create a sketch. So what we're going to do is, we're going to press 165 by 188. Okay. So we have created this base design. As you can see over here, we have a little dip over here to add the wheels. So what we're going to do is, we're going to measure this. We're going to create, it's 14 as over here. And over here, it is 65. So it's 14 by 65. So what we are going to do is, also we have to see the measurement from this to this. So it's 82. What we're going to do is, we're going to draw a line from here to here, which we're going to say 82, which is like exact. And we're going to create a rectangle, which is 14 by 65. 65. Then what you're doing is going to move this, and we're going to select all the lines of this rectangle. We're going to go create copy. So that just creates a copy, and we can move it to the other side. We have to align it with the side of the chassis and press OK. So now we have this. So now what we're going to do is press the trim option, which is over in the modify section of the toolbar, and we are going to select both these lines to create and dip. You can also create it like this. All right. So we have our base set over here. Sketch. So now we're going to extrude this.
You are in assembly mode, Avanish. You need to
That's what.
create new file.
Okay, so what we're going to do is, since we are in assembly mode, we're going to create a new file, and we're going to go part design. So what we're going to do is, we're going to do the same thing over here to here. Just quickly do that. It's 188. Okay, so now we have done the same thing. Yes. Okay. Now we have done the base design. We're going to extrude this, and we'll set it to about 10 millimeters. Fine. Okay. So now we're going to go to here, and we're going to see. Since this is a bit too complicated, we'll create the other place. So now we are going to create the stand for the motor. As you can see, it's over here. So what we are going to do is, as you can see over here is the motor. Oh no, we'll import this inside this. Since this is going to create this into assembly, we can't do that. Cancel. So what we can do instead is we're going to take some measurements from this and do the same. So now that we've done that, we're going to measure the distance from this area to this. It's around 18 inches, and over here. So this is around 18 millimeters in distance. So what we're going to do is we're going to create a sketch over here. So this sketch is going to be around, so it's going to be 18 mm, and we're going to check the height of this. Since there's a fillet over here, we cannot we cannot measure the exact height, but what we can do is we can do this, click the bottom line and the top line instead of points, so that we can get the total length. Measure. So the total height is 26. So what we're going to do is we also need the length of this, so we're gonna like this 39. So it's a box of 26 by 39. So what we're gonna do is create one over here. So it'll be 26. And also we have to create the measure the distance. 13.30. So go back here. So 13.30. So now what we're going to do is 6 seconds. Let's see. We'll create one excellent image of it. As you all might see, there are two perpendicular constraints over here, but there are no perpendicular constraints over here. That means these lines are not straight. What we're going to do is and set it exactly again 13 to 13.30. So now we're going to, as you all can see, it's still not perpendicular. So we'll have to measure the line and check if both of them are correct. Both of them are 13 by 30. Okay. So also another way of checking it is you can see over here, just before I click the sketch, there was a right angle. That means it is properly formatted, constrained. So now that we have done this, let's finish sketch. And we're going to move this, create a copy and move this to the other side because we need two motors. Since that is around 18, we're going to create another line and then move this. So now we can move this. Okay. Now that we have two, delete that and finish sketch. Now we can extrude both of them. So we're going to set it to 39. So it's 40. We'll set it to. Now we are going to smooth the edges with a fillet. We're going to set it to 2 millimeters. And set this to 2. So now that is done. So now we we have done this. Now we can open this. As you can see, with these holes we can add on this. This is the XRP motor. If we add this, as you can see, these holes are supposed to match these holes. Yeah. So what we're going to do is we're going to measure each hole. So we're going to see the distance, which is 17.50. Okay, set it to 17.50, and then we'll take the radius. Where is the radius of 1 circle or hole over here? Its radius is 1.60 and diameter is 3.20. Okay, so now in our design over here, we are going to add a motor. So, but we're going to add it a little bit higher than the ones in the image, so that we can don't need to add the hump at the bottom. So we are at 2.60. Okay, and we're going to set this 17.50 and do another one. Yeah, you go. And you can see it's 2.60 over here. And now what we're going to do is we're going to shift press M and extrude it, and then go minus, because if you go in the negative direction, it will actually cut the objects. Okay. As you can see, we've got two holes over here, and we can place the XRP motor. But before that, we'll also have to do it the other side. Instead of that, we can just, let me just undo those two holes. What we can do is we can press extrude on both of this, and instead of just doing separately each, we can just pull it so far that both the sides can get a hole at the exact same place. So now after that, our chassis with the basic motor mount is done. As you can see, this part is done. This and this area is not necessary because I took this from another design. So that's it. Now we can convert this to an assembly. Convert this to an assembly and install the motors. So we are going to do the same thing that Dhruv did. So now I'm going to use normal joints instead of chill joints. One, I'm going to select over here. Select. I'm going to select it. Here it's the same thing. as you can see. But as you can see, it's faced the wrong way. So lose.
It is not faced wrong. The shaft is remaining there. So you need to make one body.
Okay. Centered break link. Right. Oh yeah, right. So as you can see, this is happening. As you can see, we'll have to create another joint just to fix this to this area.
You need to first break link of motor.
No, this also works. So we also need it like this, right? Otherwise, how will the wheel move?
Okay.
Okay, now this is done. We can do the same thing for the other side. Can get another motor. Okay. Now do the same thing. We'll create this. Press J for joint. Add a joint. Okay. So now we have all the joints which are ready. Now we can add the wheels. Okay. Sometimes when the models are there, if they're not created properly, the arrow place where the position is different from the actual object. So now what we're going to do is press joint again. As you can see the wheel. Also over here the same thing is happening. So instead of this, you can do another option is which we can break the link. Now we're going to change the motion of this. So all of these were set to rigid, as again it's again happening. So instead what we can do is just press and press joint again. Joint over here. As you can see, something like this is keeps on happening. So what we're going to do is we're going to set a joint on this. So now it's like that. We can go and set it to the same position over here. As you can see, it keeps on doing like this. So what we can do is instead of that, we press J, but the first component is going to be this. Yeah. As we can see, now over here the motion is set, is the wrong motion. So what we're going to do is we're going to do edit joint, and instead of that, we're going to set the motion to revolute. So it makes the motor's shaft turn. And we can double click it, and as we can see, the full wheel is spinning. Now we can just do the same thing on the other side. And you all might be wondering how will this, we'll add a screw over here later. So now we're going to add another screw, this wheel. Now we're going to brake link it. I'm just going to flip it around first. Since the axis of it is set to here, the wheel is set like that. Okay. So now what we can do is do the same thing. As you can see over here, again, this is set to this. We can we can change the joint, edit joint to revolute. Okay. So now what we can do is we're gonna do the same thing as what we had done before. Sometimes you can, if this you can't see your projects like this, it's because your camera angle is set to orthographic. Make sure you can set to perspective so that you can see the inside of sometimes some stuff. Now do the same thing. That's it. Okay. That's the positions. Now what we're gonna do is set. Okay. Set this over here. Set that over there. And set it to rigid. Yes, okay. So this is the same thing. So what you do is you press it again and you can see it moves. So then just like Dhruv has said, you can do the same thing and add all the fasteners. And so this is the basic chassis you all can do. You all can add the, I would like you all to do it like an exercise to add like servo mounts. That's it. Any questions?
Any part didn't understand, you can ask now.
Yeah. Or y'all can DM us at Instagram, which is TechInfinity.ftc, to ask us some questions. Does anybody have any questions?
I think they don't have questions. So we can end this meeting.